Utility maximization is an optimization problem regarding a consumer's utility function and their budget constraint. Individuals are faced with the following problem. Faced with a set of choices, or bundles of goods, and a given and fixed budget, how will they choose the basket that will maximize their utility? In its mathematical form, this optimization problem can be formulated as an equation where the utility for a given good X is maximized, subject to a monetary constraint such that the price P of the good multiplied by the amount bought X is lower or equal to the available budget M. This equation is a generalization, and therefore it is easier to understand this optimization problem when dealing only with two goods. Thus, we modify our general equation in order to analyze the situation with two goods. In this new equation, we see that the maximum utility given by two goods, x1 and x2, is subject to a monetary constraint M equal to the price of the first good, P1, times the amount bought of the first good, x1, plus the price of the second good, P2, times the amount bought of the second good, x2. The second formula is commonly used in order to facilitate its graphical representation. The x-axis, or horizontal axis, shows the amount of good x1 consumed, while the y-axis, or vertical axis, shows the amount of x2 consumed. The indifference curve, drawn in light blue, joins points with the same utility level. The convexity of the curve shows our taste for variety, as every unit increase of a good will have a smaller effect in utility than the previous marginal increases. The level of utility increases more, the more upwards the indifference curve is set. Therefore, we would like to choose a bundle of goods on the highest possible indifference curve. Sadly, we are always limited by monetary constraints, also called a personal budget constraint. This green line represents our budget constraint. Only bundles that lie inside or on the line representing the budget constraint are feasible. However, not all of them report the same level of utility, and in fact, only one combination of goods will report the highest possible utility to the consumer. Therefore, we should choose the one that reports us the greatest utility level given the monetary constraint. As we can see, we could choose different indifference curves. However, there is only one that meets both conditions of highest utility and budget compliance. This optimization solution will be located at the exact point where the budget constraint line is tangent to the indifference curve. It must be noted that in the case shown, given the properties of the budget constraint and the utility function, one and only one solution is possible. The bundle of goods that maximizes utility while complying with the budget constraint will be composed of the equilibrium amount of good 1 and the equilibrium amount of good 2. At this point, the marginal rate of substitution, which is equal to the slope of the indifference curve, will be equal to the price of the first good divided by the price of the second one, which is the slope of the budget constraint. This optimization problem must be seen as one of two sides of a coin, called consumption duality. Indeed, a similar but opposite analysis can be done solving the dual problem, the cost minimization problem. It is also worth saying that utility maximization is associated with Marshallian demand